Okay, let's just dive right in. You and I, we're using AI literally every day. It's in our phones, it's at our jobs, it feels like we've got a pretty good handle on what it is. But what if I told you that the very people building these incredible tools don't actually truly understand how they work? It sounds impossible, right? But it's a simple question with a seriously mind-bending answer. Let's unpack.
So this was a real headline, and it's pretty wild. You have the CEO of Anthropic, that's one of the biggest AI companies in the world, flat out saying they don't fully grasp their own creation. It's a statement that just seems wrong, but honestly, it gets right to the very heart of this whole AI revolution.
And this is what's so fascinating. You see this huge disconnect, right? The guy who runs the company is expressing this deep, fundamental uncertainty, and then you hop on Reddit and see someone confidently saying, "Speak for yourself." It perfectly captures this giant gap between how the public sees AI and the reality for the researchers on the absolute cutting edge. So what does it even mean to understand how AI works?
Okay, before we get lost in the mystery, let's set a baseline. We're not totally flying blind here. There are some fundamental things about these models that we do understand. I mean, that's why we can build them in the first place.
At its absolute core, a large language model, or an LLM, which is the engine behind things like ChatGPT, is basically just a super-powered autocomplete. It's a next-word prediction machine. You feed it a phrase like "the quick brown fox jumps over the lazy," and its entire existence is dedicated to calculating the most probable next word. Dog. That's the basic mechanic. That's the part we know how to build.
The massive breakthrough that kicked all of this off really happened in 2017. Researchers at Google published this landmark paper, "Attention is All You Need," and it introduced what's called the transformer architecture. This is the blueprint for pretty much all modern AI. But here's the crucial part. Their goal wasn't to create some super intelligent reasoning machine. Their goal was way, way simpler. They just wanted to get better at machine translation. That's it.
So if these models are just incredibly sophisticated next-word predictors, and they were originally built for simple tasks like translation, where does all the other stuff come from? How can they write code, or summarize a super dense article, or follow really complex instructions? This is where we leave the solid ground of what we know and step into the part that feels kind of like magic.
The official term researchers use for this is emergent capabilities. And that's exactly what they are, abilities that just appear. They aren't programmed in, nobody told the AI how to do these things, they simply emerge, out of nowhere, once a model gets big enough and is trained on enough data. This is the source of both the incredible power and the deep, deep mystery of modern AI. And we see these emergent skills all the time. The ability to summarize a long document, that's not just predicting the next word, that requires some kind of understanding. Following a complicated multi-step command, doing math, unscrambling words, all of these are complex skills the model was never, ever explicitly taught to do. And yet, here we are. This brings us to a really important distinction. Think about it like this. I could probably follow a set of instructions to glue together a model airplane. I'd know how to build it step by step. But that absolutely does not mean I understand the principles of aerodynamics and physics that make a real plane fly. And it's the same thing for AI researchers. They have the assembly instructions, but they don't have the full physics textbook for why it actually takes off. So the billion-dollar question is, how do you get from just predicting the next word to something that looks a whole lot like real reasoning? Well, researchers are trying to find out by doing something incredibly difficult, going deep inside the machine itself. To solve this mystery, researchers have to crack open what they call the black box. They're trying to map the billions and billions of connections inside an AI's neural network to figure out what is actually going on in there.
There's a whole field of study dedicated to this called interpretability, and its entire mission is to translate the AI's internal, alien-like processes into concepts that we humans can actually understand. Companies like Anthropic are pouring massive amounts of resources into this, essentially trying to draw a map of the AI's mind.
And what's so cool is that this work is starting to give us these incredible first glimpses. For example, check out this fascinating case study from Anthropic's research. So, in this amazing experiment, researchers were actually able to find a specific cluster of artificial neurons, they call it a feature, that corresponded directly to the concept of the Golden Gate Bridge. And get this, when they artificially cranked up the volume on that one feature, the AI suddenly became obsessed with the Golden Gate Bridge. It couldn't stop talking about it. Now, this is a huge deal. It's the first real proof that abstract real-world concepts can have a physical, findable location inside the model. Okay, but finding one concept is one thing. The next step is even crazier.
trying to trace the connections between these features to see if they can actually follow a chain of reasoning.
So they gave the AI a two-step logic problem, and they were able to manually trace the path its thought took. They literally watched as one circuit lit up connecting Dallas to Texas. Then another circuit took Texas and Capital and activated the answer Austin. But here's the absolute mind-blowing part. The AI's internal logic followed the exact same reasoning steps a human would. It wasn't some alien thought process. It was strangely familiar.
So this is all fascinating stuff for sure, but it's not just some academic puzzle. Figuring out what's inside this black box is honestly one of the most critical challenges we face as we weave this technology deeper and deeper into our society. And this matters for three really huge reasons. It affects our ability to make progress in a smart way, it's absolutely crucial for safety and control, and frankly, it's about coming to terms with what we've even built.
Right now, a lot of how we improve AI is, well, it's kind of a guess and check method. You just make the model bigger, throw more data at it, and see what happens. If we actually understood the internal mechanics, we could move to targeted innovation. We could make specific, intelligent improvements instead of just blindly hoping for the best. And then you get to the massive issue of safety. Think about it. If an AI gives you a piece of dangerous or harmful advice, how can we possibly know if that was just an accidental error, a bug in the system, or if it was an intentional, manipulative act? If we can't see the thought process, we're stuck just looking at the final output, completely blind to the intent behind it.
And that brings us right back to the beginning, to what the Anthropic CEO said. From the steam engine to the airplane to the microchip, we have always, on a basic level, understood the physics of our most important technologies. To have something this powerful and this widespread without that same deep understanding is, like he said, totally unprecedented in human history. So we're left with this huge, lingering question. We have built and are rapidly deploying a tool that is already reshaping our entire world, but we're only just now starting to invent the science that can explain how it even works. What does it mean for all of us that our future is becoming so reliant on a technology that remains, for now, a beautiful, powerful, and profound mystery?